We just talked about exponential decay when we were talking about radioactive substances and half-lives. How about population? Well, at least initially, we often see exponential growth. Estimate the number of fruit flies in an experimental population, given that Q of t, the population, is equal to 20 times e to the 0.03 t. Well, this is time. T is always going to be greater than or equal to 0. That is the equation that models the population. Find the initial number of fruit flies. Well, of course, that means t is equal to 0. When I think initial, I'm always thinking, well, let's make time 0. So that would imply Q of 0 is equal to 20e to the 0.03 times 0, which is 20e to the 0. Now, e to the 0 is 1. Anything to the 0 power is 1 to give us 20. Of course it is. This is exponential growth because e is 2.71828. That's greater than 1, raised to a positive exponent. So that's going to go to the magical point 0.01. But we've got a vertical stretch by factor of 20, which is going to make sure that our point here is 0.20. Now, you could just look at this and say, whatever number out here is my vertical stretch, it's going to give us the initial value of the population as well. So a quick sketch of what we're looking at is exponential growth through 0.20. And of course, our asymptote here, y equals 0. Now, I've drawn for t is less than 0 and t is greater than 0, and here is greater than or equal to 0. I really don't need this side of it because we're talking about population, and time is going to be greater than or equal to 0 here. So we really don't have to worry about this side of the graph. Here in the second part of this question, they've asked us, how large is the population after 72 hours? Well, we have to be careful with time because this t sometimes is years, sometimes it's days, sometimes it's hours, and sometimes we have to translate 72 hours into 3 because that would be 3 days. But for this problem, t is hours. So we don't have to say that's 3 days, it's actually 72 hours. So Q of 72, this is simply a matter of plugging and chugging, e to the 0.03 times 72. Now that is the exponent on our Euler's number e, 2.71828. And when we do that, we get about 173 flies. That's to the nearest fly. So based on the knowledge that we just gained from those that first part of the question and the second part together, we know it goes through 0.20 and 72 is the time on the x-axis or the time axis, and the resulting number of fruit flies was 173. So I know it goes through these 2 points and has this exponential growth look to it. Of course, we don't have to worry about when time is negative, so I would erase this side to say, well, t is going to be greater than or equal to 0.